Assalamualaikum warahmatullahi wabarakatuh and greetings to Dr. Karus. I am Nurida Bintun Hisham. My matrix number is AE180056. So today I would like to present about the abstract of this project. So first, the goals for this company is to create one conceptual model of an extra high voltage EHV, 132 kilovolt or 275 kilovolt suspension type of overhead line insulator. Then we have to figure out how to design and select the best high voltage suspension model line voltage insulator that can survive environmental damage. This company called Brimstone Engineering Group (BEG) has decided to design the suspension insulator with the help of a few of clicks. The material of insulators that can be chosen are from several types, such as ceramic, polymeric, and also glasses. So we would like to pick the glass since it owns benefits of using them rather than other materials. So the glass insulator can easily detect impurities and bubbles since it is transparent. Other than that, since the mechanical and electrical capabilities of the glass are not impacted by aging, it has a very long service life. Then the glass materials have a lower relative price when compared to other types of insulators. The glass insulator will be designed in 2D drawing by using the AutoCAD software, and it contains 11 sheets of glass insulator. After that, the simulation will be run in the FEA simulation software, and it used to collect data and also analyze the performance with graph. The next slide, it is about the problem statement. Our focus is on transmission overhead lines that basically can be seen along the road. This project is concentrating on an extra high voltage EHV, which is 132 kilovolt. Normally on this large transmission line with a high value of voltage, there must be an excess current that came up from the substation. Hence, an insulator plays an important role in this operation. The overhead line conductors on the poles are supported by an insulator, which prevents current flow toward the ground. Overhead line insulators can be divided into several types, and the chosen one is cap and pins type with 11 sheets of glass insulator. So each insulator consists of numerous insulating discs and used in transmission and distribution system. So for this project, students need to design a suspension type overhead line insulator based on the specific standard requirement. The insulator must be able to withstand the tensions that could occur between the conductor and the earth. The flashover distance is the minimum distance between the conductor and also the earth surrounding the insulator body.
Hi, I'm Farsha Akila Bedina Hisham, matric number AE180072. Okay, now I'm going to present the objective of our project. So the first objective is we want to design extra high voltage suspension type insulator of overhead transmission line by using 2D drawing software. The second objective, we want to study the best material to design suspension insulator for high voltage overhead power line. The third objective is to simulate the high voltage and electric field distribution to the proposed prototype by using FEMM software. And the last objective is to analyze the performance of the design prototype when stressed by environmental impact. Next is the scope of our project. First, the material chosen for the project is a glass insulator. Next, the insulator prototype will be designed in 2D using AutoCAD software. Third is the finite element magnetic software will be used for the FEA simulation. And the last scope is the suspension insulator in the form of stacked insulator string and fitting of cap and pins.
Now we move to the next slide, which is about the glass insulator characteristics. The benefits of using these glass insulators include a slower aging process, great electrical strength, and also high mechanical strength. The locking device is made of stainless steel and it's part of the insulator of fixation. So the material characteristic, the insulator is designed to use glass material for the best endurance and also the performance. The performance of the glass insulator is suitable for dry and also wet conditions. For the electrical characteristics, there are several calculations that have been made, which is the system voltage is 132 kilovolt, the clippage distance is 4,118.4 millimeters, and also the length of the insulators is 2 meters. The material used for the insulator is glass because toughened glass has a lot higher strength than porcelain, which is a form of the type of insulator, and it is much smaller and lighter. It is a good thermal insulator too. The most typical environmental effect that has been divided into several parts which can cause damage to an insulator, such as organic, inorganic, and also the water pollution. This is the 2D drawing design by using the AutoCAD. As we can see on the left side, there is a single shade of insulator, glass insulator that has been designed, and also on the right side is the 11 shades of the insulator. Okay, this is the design in the FEMM software. So basically the design is very similar with the design in the AutoCAD software.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Muhammad Murad. My metric number is AE180065 and I'm from Group 3 from High Voltage Section 2, and I'm going to present about my methodology for my project. So initially my project will came out to make a research about high voltage insulator based on internet journal and article. Then the project will follow up to determine the type of material that's suitable to be used as an insulator, such as glass, ceramic, or porcelain. Then the project will continue to draw a proposed prototype of HV insulator using AutoCAD software. It then be simulate the potential voltage, magnetic flux density, and magnetic field intensity using FEMM software, considering the proposed prototype. Then, if the error occurred during the simulation, the block must be verified, then the design must be simulated once again. Then the project will continue to proceed plotting the response of potential voltage, flux density, and field intensity. Then lastly, the result will be analyzed from the simulation. So, Assalamualaikum, my name is Muhammad Hakimi, and for this part, I'm going to show the simulation by using FEMM software. So basically, this is the design that have been proposed by us, which was the 11 disc glass type insulator. So basically, this design consists of several materials that we must insert, which was air, which represent as an environment, FRP, which will represent as the steel rod of the insulator, silicon rubber, steel, which represent as a housing, and also glass that will act as the insulator. So then we must also set the property, which is V equals to 0. Then we also must check the conductor, low and high. Then after that, we can simulate our design. So this process is known to be meshing process. So this in order to get the potential voltage, flux density, and also field intensity. So lastly, this is the result that we got for meshing process. So this simulation represents for the potential voltage. So this is the result for our design. For normal condition, which is clean air with normal insulator. So, Assalamualaikum warahmatullah. My name is Muhammad Hakimi Memang Umrat. So, following the previous part for our group video, it shows the simulation by using FMM software. So, following the result of the normal condition, we make several condition based on the past research, which is contaminated insulator with clean air condition. So each of the materials have a relativity permittivity values. So for contaminated is 82, air is 1, steel is 1, FRP core is 5, and glass is 6. So this is the result for contaminated insulator by using meshing process as have been explained by previous part from the video. So next was the contaminated insulator with contaminated air condition. So the difference from the previous part is this part is using a contaminated air. So in the previous part is we using an clean air condition. So basically this is with a contaminated insulator with a contaminated environment. So next part is wet insulator with clean air condition. This situation is a wet insulator but with a clean air condition. So this is the result for meshing process. So and lastly, this is for wet insulator with contaminated air condition. So in this situation, the insulator is wet and the air condition is contaminated. So this is the result for wet insulator and contaminated air condition.
Okay, for the next part, I'm presenting the result from the FEA simulation. So this is the voltage distribution graph for the contaminated insulator with clean air condition and contaminated insulator with contaminated air condition. So from both condition of contaminated insulator, we can see that both have the same value of voltage distribution, which is reach 130 kilovolt. For the performance graph of flux density, it shows that the contaminated insulator with contaminated air condition has higher flux density compared to contaminated insulator with clean air condition. For the field intensity graph, it shows that the contaminated air condition also has higher field intensity compared with contaminated insulator with clean air condition. Next is the condition of wet insulator with clean air and wet insulator with contaminated air. So the voltage distribution for wet insulator with clean air condition is slightly higher compared to the contaminated air condition. The clean air condition reach 130 kilovolt and for the wet insulator with contaminated air reach 125 kilovolt. For the distribution of flux density in wet and contaminated air condition is lower compared to the flux density for a wet insulator with clean air condition. And the last is a field intensity graph for wet insulator condition. So the distribution of field intensity in wet and contaminated air is lower than the field intensity for the condition of wet and clean air insulator. So thank you. So that's all for result. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Akmal, I'm going to show you about the presentation of safety reassessment, hazard and code of conduct. Okay, my entry number is AE18002. This presentation, I have going to cover part of safety reassessment. The test, we're going to do a dry test for HVAC glass insulator. And then for the purpose of this test is actually to analyze the system flashover power frequency for wet test and dry test. Okay, there are 4 steps for the procedure of this test, which is for the dry test, the insulator was energized with the both positive and negative polarities of the, and the second, the AC voltage will apply and raise until the flash over is occurred, and then repeat the process 5 times to get the mean breakdown of the voltage. And then the fourth is the for wet test, repeat the dry test procedure but with the insulator being sprayed and continuous with water using nozzle. Okay, and then kita do at the hazard checklist. Here is the assessment. Okay, there are 2 things that might be happen, which is electrocution and sleep. Okay, to measure from this happen is wear PPE suit while conduct the testing. This for the sleep. Being do the wet test is carefully handling water testing and always wipe the equipment until dry before testing. Okay, this is our hazard checklist. Sorry, from this we can fill in by using this one. Okay, and then the code of conduct. Okay, there are 5 things that code of conduct we implement, which is underground terminal of the test equipment apparatus under test should be considered energized. Precaution should be taken to prevent external contact of light terminal by personnel. Safe grounding of terminal should be taken precedent over proper signal grounding unless other special precautions have been taken to ensure personal safety. The routing and connection of temporary wiring should be such that against accidental interaction may create hazard or non-personal equipment. High power testing involving a special type of high voltage measure. The level of current is very high. Safety glasses containing should be worn by all the personnel observing high power tests even when the electric access is not expected. Okay, that's it from me. Thank you.
So last but not least, for our conclusion for this project is we managed to obtain the suitable material that will be used as an insulator. So the glass material is suitable for us as a protection for high voltage. So basically this project aims to design an extra high voltage suspension type insulator by using glass material as our decision to take glass as a material. So the performance of the design insulator has been tested and analyzed in several conditions such as wet and contaminated conditions. So lastly, the design of glass insulator had met the criteria of good insulator for protection from high voltage. So that's all from our group. Thank you.